Hello, everyone. Good morning, evening, and afternoon. Dear authors and invited guests, I welcome you to Technical Session 1F. My name is Amog Dhamdere, and I will be moderating this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is a great pleasure to welcome all of you to the third International Conference on Innovations in Biotechnology and Health Sciences, BioCom 2026 in Bangkok, Thailand. The third edition of this conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April in 2026. I hope all of you will enjoy the knowledgeable and interactive sessions we have planned throughout the day. In this particular session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for questions and answers. And on completion of 9 to 10 minutes, I will be raising a gentle reminder. There is another request to all the participants that all of you please stay connected with us throughout this session. And if you have any queries or updates, you can write it to me in the chat box. Just before we start the session, I would like to introduce all of you to the session chair for this session, Dr. Shubhajit Roy Chaudhary.
Hello.
Dr. Shubhajit Roy Chaudhary is currently a professor at the School of Computing and Electrical Engineering and chairperson of the Center for Human-Computer Interaction in the Indian Institute of Technology in Mandi. His research interests span around the development of biomedical embedded systems, neurodiagnostic and neurotherapeutic systems, VLSI architectures, and near-infrared spectroscopy-based non-invasive diagnosis. He is keenly interested in the educational system and its necessary transformation. Sir, I request you to kindly address all of our participants.
Uh, so a very good morning, good afternoon, and good evening, as Amok rightly said. I don't know where each of you are sitting. Uh, so I'm Shubhajit Roy Chaudhary, and I'll be chairing this session. In this session, we have altogether 10 papers. One, two, three, four, five, six. No. Altogether, one, two, three, four, five. Five papers are there, right? So each paper for each paper will have uh, 8 minutes of presentation, followed by 2 minutes of Q&A. So that's how the session will go. And so I all welcome you to this session. And if any question is coming out of the presentation, I request the other participants to kindly postpone the questions till the end of the session, end of the presentation. So the first presentation is a hybrid IoT AI framework for real-time predictive monitoring in intensive care units, and the paper is going to be presented by Radha Gawande. Over to you, Radha. Please share
Excuse
your
me, sir.
screen.
Yes, sir.
Yeah.
Sir, it's okay if you don't introduce all our authors. I will be doing that.
Okay. Okay. Because I don't see all the authors over here, right? So
Yes, sir, I will
yeah,
be
you can.
introducing them as they come.
Yeah.
Okay, thank you.
Yeah. Please take over, Radha. You have 8 minutes for your presentation.
Yes, sir. I share.
Amok, are you looking at the time?
Yes, sir, I will be taking care of the time as well.
Sir, it is visible.
Okay. Yeah, you have started
Yes, ma'am, you
sharing
can
your
start.
screen.
Good morning, respected dignitaries and everyone. I am Radha Gawande from Dattamegi Institute of Higher Education and Research. It's it is an honor to present on our works to BioCom Thailand 2026 under ICT IS 2026. In our presentation's title is Hybrid IoT Frameworks from Real-Time Predictive Monitoring Intensive Care Unit. This research is proposed to smart healthcare system that combine IoT device and AI algorithm to monitor ICU patients and in real times and predict the critical conditions before they become servers. These slides show a flow of my presentations, introductions, objectives, literature review, purpose, methodology, evaluations, metrics, and real-time applications, future scope, conclusion, and reference. And this slides is outline the structures of my presentations is introductions. Most important slide is intensive care unit is a high sensitive environment where patients required immediately in continued care. It is ICU patients need continuous monitoring and traditional systems only monitors vital signs. They are reactive alters only after problems occurs. The solutions of these problems, AI-based system analysis data continuously. They predict disease before they become critical. Technologies used in this system is heart rate, sensors, heart rate, BP, and oxygens, AI, and machine learning. Objective. My first objective is the core ideas of the health risks advisors is the main predictive healthcare. It is real-time monitoring is use IoT device to collect patients' data and continuously include heart rate, oxygens, levels, blood pressures, and temperatures. My second objective is use ML models is detect disease like cardiac arrest, and third is automated alert system sends alert to doctor instantly. And my fourth point is better decisions making. Doctors get instead from AI predictions. The main aim to create the smart system that not only monitoring patients but also predict and alert critical conditions in advance. Literature review. A recent study in healthcare technology emphasized the importance of integrated IoTs and the smart patients monitoring system. Smart. It is IoT, continuous monitoring, AI improve predictions accuracy in machine learning models to conclude neural network. The common model used in CNN is it is image and pattern detections, and LSTM is long short term memory time series data to store. Random forest and XGBoost is classifications is used in the research indicates that AI based predictive system, and this is previous data studies confirm the combinations of IoT with AI significant improve early detects and accuracy of ICU monitoring system. Purpose methodology, one of the base data is received, it undergoes processing including data cleaning, normalizations, normalizations and noise removal to ensure accuracy. Data collections. A sensor collect real-time patient's data processing, cleaning, removing errors. Normalizations is standardized values. Noise removal is improve accuracy. Apply ML models is CNN, LSTM. Um, Basis on the analysis, the system grade generate real-time alerts and display patients. This is the process of purpose methodology step by step. I show in diagram wise and real-time applications, ICU monitorings, remote patients monitorings, telemedicine, emergency response system, elderly care, smart hospitals. Evaluations matrix is accuracy is measures overall correctness. Precisions indicate how many predict positions cases are accurate correct, and recall sensitive ability to detect real critical cases. F1 a score balance between the value between precious and recalls. Latency is measured to time delay between data collections and response to output. uh, thoughtful data processing speed, and future scope. The future scope is integrated with wearable devices and smart healthcare tracker. It's a smart. It means a smart watches and the smart watches and fitness band. Use of advanced deep learning models from improve accuracy. It's deep learning from better accuracy and edges computing. It's implemented of edges computing to reduce latency. Edges computing is fast processing near data sources. Blockchains is secure patient data. Rural healthcare under healthcare system is expand to remote users. Develop of personalized healthcare solution with using AI customer treatment plan. It's already generated. In the futures, the systems can become more advanced and secure and accessible to large populations. Conclusion: This research demonstrate that integrated IoT and artificial intelligence science to significance to improve ICU in monitoring system is the ICU monitoring system. The purpose of hybrid frameworks is enable real-time data. By using advanced machine learning and deep learning, especially of hybrid and CNN, is approach to system achieve highly accurate accuracy in detecting patients' dexterous patients. It is using models of CNN and LSTM improve patient safety, fast detections, healthcare quality. This research show the integrated IoT and AI transform healthcare in a predictive system, improving patients' outcomes and saving lives. This is a reference. Thank you. Thank you for your time and attention. I will be happy to answer any question.
Thank you
So
for your presentation, ma'am. So please,
the
if you
floor
have
is
any
now open
questions.
for questions.
Yeah.
Yes,
So if there are no questions, then I have a question. So how do you really, what is the accuracy of your prediction? Have you done any analysis on that?
yes, a 15% to 19%.
15 to 19%. So then you really have to seriously work and figure out how to improve the accuracy of your prediction.
Yes,
Yeah. Okay, let's thank the speaker.
thank
Uh,
you.
Thank you so much, ma'am. Give me
Thank you,
just a
sir.
second.
so our next
Yeah.
paper is a survey on climate pattern detection using data analysis, and the paper is going to be presented by Priyanka Patel. Is Priyanka out here?
I would request any of the co-authors if they are present as well to start presenting. Okay,
I
I don't
don't think
think they
she's
are there.
present.
Yeah, we can move on, sir.
Okay, so then next, let's move on to the third paper.
It
The
will
third
be
paper in this session is exploring how biomechatronics and CFD simulations can help determine health risk conditions, and the paper is going to be presented by Hector Rafael Morano Okuno. Over to you, Hector.
Yes, I'm here. Sorry. Um,
Professor Chaudhary. I will introduce the speakers. You don't have to do it.
Okay, okay.
Yeah. Okay. Thank you so much. Sir, you can start presenting.
okay. Um, Let me share the presentation. Mhm. Share. Okay, so thank you. Hello, everyone. I'm Hector Morano. I work for Tecnológico de Monterrey, campus state of Mexico. The title of this presentation is exploring how biomechatronics and CFD simulations can help determine health risk conditions. So this is the agenda I'm going to follow. First, I will give a brief introduction. Then I will mention the objectives of this work. Subsequently, I will describe the methodology that we use. And finally, I will share the conclusions and future work. So biomechatronics allows us to develop multidisciplinary applications that exchange information for the common good. In this research, bioinformatics is used to analyze biomarkers that fit CFD simulations to obtain blood flow velocity profiles in a segment of an artery, thereby enabling monitoring of a person's health during physical training. Depending on the types of sensors used to measure each biomarker, the units will vary. They will therefore be treated as dimensionless values, standardized to the range of 0 to 1, with 0 corresponding to the minimum and 1 to the maximum. So the objectives of this work were two. The first one was to determine whether blood flow velocity profiles can be obtained using biomarkers and CFD simulations. And the second one was to investigate whether the information from the CFD simulations can be used to feed a biomechatronic system for monitoring a person's health conditions. So the computational resources that we use to manipulate biomarker information, patient data, and CFD simulation results. We use Python language on laptops with i7 processor at 2.5 gigahertz and 32 gigabytes of RAM. The CFD simulations were performed using ANSYS Fluent Workbench 2025, and the CAD models were generated using CATIA V5. So now in this slide, we can see the methodology that we employed, comprising the steps used to develop the research work, as shown in this figure. So now let's describe each of them. Initially, the individuals or patients whose health conditions will be monitoring must be registered. They will be designated simply as patient 1, patient 2, and subsequently the biomarkers that will be used to fit the blood viscosity model must be selected. This will depend on the type of sensors available to measure the values. It is recommended that the sensors be non-invasive so that they can be used while the individual or patient is exercising. Some examples of biomarkers related to blood viscosity are shown in this table. The model for calculating blood viscosity is shown in this slide, where N is the number of patients. If there are 6 patients, each with their biomarker measurements, equations 1 can be used to calculate blood viscosity. So in this table, we can see an example of the calculation results. To determine the arterial pressure gradient, it will be necessary to know each patient's age and the intensity of the planned physical activity. So the intensity will be standardized using a weight scale where 0.1 correspond to low intensity and 1 to high intensity. So therefore, the effect of exercising intensity on person age will be considered intermediate with a value of 50. Table 3 shows each patient age and the intensity of the physical activity they will perform. The model for calculating the arterial pressure gradient is represented by equation number 2. The artery in which it is suggested that the blood velocity profile distribution be measured and calculated in the brachial arteria is in the upper arm. So to determine the velocity distribution, we employ CFD simulations. To obtain the velocity distribution in the brachial arteria, a 100 millimeter long segment with a 4 millimeters radius was modeled in CATIA V5. So the boundary conditions used are listed in this table. The velocity distributions for each patient are shown in this figure, in figure 2. And in figure 3, we can see a longitudinal section of the artery for patient 3 with the velocity streamlines visible. Now in this figure, the safe blood viscosity range 3 to 4.5 centipoise is identified in color green, and in the safe blood velocity range from 0.25 to 0.7 meters per second in magenta. The area where these ranges intersect represent the ideal range of blood velocity and viscosity. So the 6 patients are circled. Those overexerting are shown in yellow, and the remaining patients are shown in red. Only patient 4 is within the safe viscosity range. No patient is with the safe velocity range. Patients 1 and 2, 3, and 5 are outside the safe velocity and viscosity ranges. So this type of representation can help us to determine the health risk condition for the different patients. So here are the conclusions. So using biomarkers related to blood viscosity and CFD simulation, it was possible to obtain the velocity distribution in the artery. Furthermore, the results can be used to feed a biomechatronic system to identify health risk factors in a person during the physical activity. So thanks to CFD simulations, the artery's geometry can be easily modified, and some obstructions can be added by internal roughness or malformations. Depending on the biomarkers and available sensors, the models used to estimate blood flow velocity and exercise intensity can be vary. The characteristics of the sensors will depend on the type of applications to be developed. So whether it is gathered towards monitoring a vital sign or biomarker in real time. So as future work, we distinguish the following task. It is advisable to assess whether CFD simulations can capture more complex biological phenomena, such as synovial fluid, or which lubricates joints, and cerebrospinal fluid, which protect the nervous system, just to mention a few of them. And it's pertinent to investigate biomechatronic IoT applications to determine whether wireless data transfer will not interfere with the sensors use, and whether the bandwidth will allow the transfer of all required information. So thank you very much for your attention. If there are some questions, I'd be glad to answer them. Thank you.
Thank you for your presentation, sir. I would now like to ask our session chair if he has any questions for you.
Any questions from the participants? Okay, Dr. Morano, I was wondering that uh, so with this whatever biomarkers you have chosen, you have assigned some weights to it, if I correctly
Ye-
understand, right?
yes,
So how did
we.
you come across to those weights?
Well, we have to choose that type of sensors, and after that we have to create a model to represent the signals, and then we can start using this proposal to see if we can measure some risk, or we can detect some risk conditions when people are exercising.
Okay, okay. Thank you. Thank you,
Thank you.
Dr. Morano, for your presentation. Now the
Thank you so
next
much for your
presenter.
presentation, sir. So our next presenter is Rohan Dafare from the Datta Media Institute of Higher Education and Research in India. And the title of the research paper is No SQL and SQL for Today's Data Intensive Workloads. Sir, I request you to kindly unmute yourself and start presenting. If any of the co-authors are available as well, you can start presenting.
I don't think anybody is there, so we can go to the next paper.
Okay, we can move on. So our next presenter is Anshuman Prajapati from the Charotar University of Science and Technology in India. And the title of the research paper is Transfer Learning Based Facial Skin Analysis with Attention Guided Feature Refinement. Sir, I request you to kindly unmute yourself and start presenting.
Yeah, good morning, panels. Am I audible?
Yes, you are.
Yeah, so let me share my screen. Yeah, so is this visible?
Yes, the screen is visible and you are audible as well. You can start.
Yeah, okay. So good morning, all everyone present over here. Myself, Anshuman Prajapati from Charuta University of Science and Technology. I am currently doing my BTech in Information Technology. And today, the title of my paper and the presentation itself is the Transfer Learning Based Special Skin Analysis with Attention Guided Feature Refinement. So, what is the main like challenge and the problem we are working on is like classifying in our facial skin conditions into multi-level classification, right? So, what previous work has been done is like multi-class classification and a single class classification. Like, for example, we have multiple skin condition classified into six classes, right? Like people may have dark circles, open pores, as well pimples, wrinkles, etc. So what previous work has been done is classifying into multi-class classification, right? Like either you have pimples or dark circles, like 0 or 1 probability, right? What I am trying to approach is multi-label classification. We might have multiple condition present simultaneously co-occurring with each other, right? Like pimples and dark circle co-occurring on the face at the same time. So what we are trying to do is doing multi-label classification. So for that, the challenges for our key challenges for our task is are inter-class similarities as presentation, right? Like fine lines and wrinkles. So these are the type of things which are similar to each other. So it is hard to classify them into multi-level, as well as giving the probability of what amount of present threshold is present for that particular condition. And also the main challenge for our in the healthcare domain is which is the data scarcity, right? So since it is a very ethical and sensitive topic for to work in the healthcare condition using the machine learning and AI, data scarcity is currently present over here. So what approach I have done for our solution is like the obvious approach first anyone can think of is the custom CNN model, right? So we have created our custom CNN. Being a machine learning enthusiast, we already know that due to the lack and scarcity of data set images, right? To train the custom CNN on limited resource and hardware available over here, it is very hard to achieve that high performance from our custom CNN. So what we have approach is the using the pre-trained model and using the transfer learning approach on the efficient B0 model. So it is a pre-trained model available, which is trained on the ImageNet dataset, which spans over thousands and crores of images dataset, and it has already trained its weight for the classification. So using the image efficient net B0, we have approached and implemented using that, and we have obtained the performance. So what we have found that there is a lack of attention mechanism. So we have included the convolution based attention mechanism over the efficient B0, which improve its performance over. So what we have done, I will show in the next slide. Yeah, so for our experiment, the setup was we are using around 1800 facial skin analysis divided into the 6 class multi-level annotation, which here shown. So for the training comparison, this is purely experiment based. So focusing more over on the efficient at B0 plus CBAM, we are using the 30 iteration, which is epochs divided into 2 parts, 5 plus 25. We are using the batch size of 16 images due to the GPU I was using was limited to 4 GB of VRAM. And the learning rate and weight decay are the trial and error method, which are gain over multiple experiments. Yeah, so what is my proposed framework for this? That attention enhanced transfer learning, right? So this is the already available efficient B0, which we are using it for the mobile application deployment as well. So using this efficient net B0, we have created a CBAM convolution block attention module, which involves 2 types: channel attention module and the special attention module. So what channel attention module shows is that what to focus on. Like for example, we have pimples condition present to our face, right? So pimple, the redness, the like oily part and the shiny part indicates there might be the pimple possible there. So channel attention module is spans over multiple channels and it shows what to focus. Then in parallel, the images, the pixels are passed to the special attention modules, which are showing where to focus, right? Like this redness and the oily part is present over that particular cheek portion also. So the model must ignore the other part, which is hair and chin and these fine lines. So it can focus on what that particular area or region of interest. So this attention mechanism module CBAM improves the already trained model efficient net B0 for our particular test case. So this is our trajectory of the training, which as first the baseline efficient at B0 has the less than CBAM, but eventually over the time, our our approach CBAM improves over the time, and in the like for the validation macro, also we can see that it has been improved the performance cross the threshold of existing efficient at B0 model. So this is our overall performance comparison. Like for efficient B0 and efficient B0 with the CBAM, which is our approach, we have like we can see the improvement for the macro F1, which is significantly over 5 to 6%, and for the micro F1, which is around 4%. So including this single attention mechanism on the smaller data set, we can see there is a higher jump in the performance of the particular model. And for the particular per classes of the evaluation of our model, we can see that for the fine lines is has been improved by 18% of the performance. For the dark circles and hyperpigmentation, 10 and 9% respectively. So for like it also depends on the class wise how much data is present on that particular class. So for the limited data set, we can see that including an attention mechanism along with the pre-trained model, we can improve that particular performance of the model itself by a huge amount. And for the interpretability, we have used the GradCam approach, which is present over Python. Uh, for like normal people, they can see that which condition is present over where. So this is the one of the interpretability model we have integrated into our model. So these were our observations. And for the future work, I have been thinking of that using a larger data set and resource efficient machine for further training of existing models and explore more attention mechanism, different attention mechanism for the large amount of data set for the real world generation. So these were the references, and this was from my side, and I'm open for the any question is there.
Thank you so much for your presentation, sir. I request our session chair to ask any questions that you might have.
Okay. The floor is open for questions. If anyone has any question, can ask. Okay. If there are no questions, then I do have a question. So
Yes,
you
sir.
have used this facial skin. Now, there, of course, did you look for different anthropological sects in your in building your cohort for the study? Because I know that different anthropological sects have different kinds of textures of the skin, and that may create considerable hallucinations in your model. One big problem is, for example, these Mongoloid people, they have these eruptions coming in the
Yeah.
screen very early. And similarly, the Caucasians have a very smooth skin surface. We are somewhere in between. When you are going for this, looking for these eruptions in the skin, it also becomes very important to know that what kind of subjects you are looking for, because it has got a significant contribution with respect to the ground truth or the baseline
Yeah.
condition for the normal surface of the skin. Yeah.
Yeah, so I have work using for the Asian, like mainly focusing on the South Asian region of our region. Along with that, the data set mainly consists of the people of that particular Asian races. So our evaluation has been done over this particular region of people only. So like I have been gone through the previous research work done in this field. So I have come through that for that particular different races, and there might be over different textures and the environmental condition present over different area, right? So these contributes like major into that particular along with only the texture. So I have explored that for the different countries and the region, but mainly I have worked for the South Asian data set only.
Okay. Okay. That's good. Uh, my suggestion is that down the line, you can think of actually expanding it for other regions across the globe as well, to
Yeah.
universalize your hypothesis. Otherwise, it will get limited to a particular region only. Yeah.
Yes, yes.
So thank you for your presentation.
Okay, thank you, sir.
Thank you so much for your presentation, sir.
So I think that's all for this session. So let me just add my own concluding remarks. In this session, we had nice presentation of four papers. Um,
Excuse me, sir.
yeah.
Yeah, so like we have skipped one paper of Priyanka Patel, right? So the co-author is now present over here.
Okay,
Do
we
we have
can.
time?
I think we have time, sir, because we had skipped their presentation. So, are you talking about Ms. Priyanka Patel, right?
Yes, yes.
Okay. So, yeah, we can go right ahead with that
Okay,
presentation.
so we can have the presentation of
Yeah.
this.
The title of the research paper is A Survey on Climate Pattern Detection Using Data Analysis, which will be done by Priyanka Patel from the Charotar University of Science and Technology. I think the co-author is present, right?
Yes, sir.
Shri
Am I
Pathshala.
audible? Yes, sir. I am audible.
Yes, you are
Yes,
audible.
yes,
You
you're
can start
audible and
presenting.
visible as well.
Okay, sir. So I will share my screen. Is this visible, sir?
Yes, your screen is visible. You can start.
Hello everyone. Good morning, respected judges and participants. My name is Ashwi Patchala, and today I am presenting our work on climate pattern detecting using data analysis. So, first is a climate change is one of the most critical changes facing our world today. Detecting a climate pattern at an earlier stage is essential for disaster prevention, agriculture planning, and environmental protection. So first is a introduction. So climate patterns such as a temperature variation, rainfall cycle, and atmospheric changes have a direct impact on our daily lives. Traditional methods mainly rely on statistical analysis. However, these methods are often slow and struggle to handle large-scale modern data sets. Therefore, our project focus on leveraging artificial intelligence and machine learning to enhance climate pattern detections. So next is a problem statement. The existing approach faces three major limitations. First, they assume that climate systems are stable, which is no longer true in today rapidly changes environment. Second one is they are not capable of efficiently processing massive data set generated by satellites and sensors. And third one is they lack real time processing capability, which limit timely decision making. Due to these challenges, there is a strong need to intelligence cable and real time systems. Next is uh, research objective. Our project focus on three main objects. First, to detect climate pattern using advanced machine learning models such as SVM, SNS, and LSTM. Second one is to improve prediction accuracy compared to traditional techniques. And third one is to integrate multiple data sources, including satellite data and IoT sensors, into a unified systems. So next is a data source of climate detection. So we utilize a multiple source of climate data: satellite data for large scale observation, weather station data for ground level measurement, reanalysis data set for historical trends, and RT sensor for real time local data. And however, managing this data is challenging due to its large volume, complexity, and verify formats. Next is a analytics methodology. So our methodology consists of three key approach. First is a statistical method such as a PCA of initial pattern extraction. Second one is a machine learning techniques like SVM and clustering for classification and anomaly detection. And third one is a deep learning method including CNN and LSTM. So CNN is used to analyze spatial patterns such as a temperature maps, while LSTM helps understanding temporal patterns like sensual variations. Next is a processing and tools technology in stack. Before applying these models, we pre-process the data by cleaning and normalizing it, extracting relevant features and integrated multiple data sets. We use to such as a TensorFlow, PyTorch, Spark, and cloud perform platforms like Amazon Web Services to efficiently handle large scale data. Next is a application. So this system has a several real world application, whether forecasting, disaster management, then including flood and cyclone prediction, and a long term climate monitoring. This application can support governments and organization is making informed decisions. And future scope is in the future we aim to enhance model temperancy using explainable AI and develop a real-time earth simulation through digital twin technology. So in conclusion, our approach demonstrated how AI driven techniques can significantly improve climate pattern detection and prediction. Thank you for your time. I would be happy to answer any questions.
So
Professor Chaudhary,
the
any
floor
questions for
is
us today?
open for questions.
Yeah.
If any participant has any question, can ask. If others don't have any question, then I have a question. First of all, nice work, nice attempt. Uh, One big problem with respect to AI models when used for weather prediction is in these days of climate change, where the year to year variation of weather patterns is substantially changing, it becomes very difficult to get a general trend of the weather patterns. I'm residing in Himachal Pradesh, and I know of late for the last 5, 6 years, I have not been able to at least use my own intelligence and use my own natural intelligence. Forget about artificial intelligence. I've not been able to use my own natural intelligence to figure out a generalized trend of the weather patterns. A very simple example I'm telling you. Usually, from mid-January to mid-March, it's very rainy in Himachal Pradesh. Almost every week, it rains for 2 to 3 days. However, this time, the January and February became almost dry, and it started raining only after mid-March, which means the cycle is going very differently. Right. So last year, I mean, usually the monsoons over here last till the end of August or maybe the first week of September. Last year, it continued till the first week of October or so. So things are actually very much changing. Now, 3, 4 years back, I remember both this IMD and the SkyMed, they badly failed with respect to the date of retreat of monsoons from India. And there was this Post-Stamner Institute for Climate Change in Berlin, in Germany, where a lady named Sophie, I forgot the surname, she actually accurately predicted that the monsoon would start receding from India on and from the 6th of October, and it started receding from the Jaisalmer and suburbs from the 6th of October. And when on being asked later on, she said that she was using physics all through her calculations, and machine learning and statistics was introduced into the model only at the end. So, so I would like to know your views on the same. Yeah, over to you, Ashvi.
Yes, sir. Um, so you are absolutely right. Due to climate changes, weather pattern are becoming highly unpredictable, and even human is often no longer reliable. There is also one of the biggest challenge faced by AI-based models. So traditional machine learning model assume that past pattern will continue in the future. However, in a real-world climate system, this assumption often fails because the data distribution keep changing over the time. This is known as a non-stationary stationarity in climate data. To address this issue, our approach does not rely on the single model on a, or only historical trend. And first, using deep learning model like LSTM, which can capture complex temporal variation and adapt better to changing sequences. And second one is integrating multiple data resources such as a satellite observation and real-time sensor data, which helps the model stay updated with current conditions. And third one is a combining physics based understanding with data driven models. As you mentioned in the example, physics based model provide strong foundational behavior, while machine learning helps in a fine tuning
10
prediction.
seconds. Yeah.
And so rather than replacing traditional method, our approaches support a hybrid system where physics and AI work together. And while um, our goal is to improve adaptability and prediction accuracy under changing climate conditions.
Yeah. So I think that's actually a good observation. So I would suggest that maybe you can talk to your professor and see whether you can incorporate physics-based models down the line, and then on the top of that, you can give an AI topping for local trend setting, whatever. Otherwise, otherwise the way the weather patterns are changing so rapidly, I don't think I'm not. I'm a bit skeptical whether the only AI based predictive models for diurnal weather predictions or even seasonal weather predictions, whether it'll work well down the line or not.
Yeah.
Thank you, Ashvi, for your nice
Thank you, sir.
presentation. Um,
Thank you so much for your presentation, ma'am. I think we have one last presentation left, uh, which will be done by Supriya Narad. She is one of the co-authors for this paper. And the title of the research paper is No SQL and SQL for Today's Data-Intensive Workloads. Ma'am, if you are present, you may please start presenting.
Yeah, thank you, sir. I'm sharing my presentation. Yeah, so I have shared presentation, sir. Is it visible?
Yes, it's
yeah,
visible
it
and
is
you are
visible.
audible as well.
Yeah, thank you, sir. So my paper ID is 3 and title it is No SQL and SQL for Today's Data Intensive Workload. And authors of this paper are Rohan Dafre and myself, Supriya Narad. So this is the outline of my presentation. Now, why I have chosen this topic first of all, because the need of DBMS, SQL, it is known to all of us already that we are using this as a database management system. But nowadays or before some 5 years, we know that we are using NoSQL also, as there will not be requirement to query the SQL only. So it is called as NoSQL. So modern data intensive workloads are driven by real-time analytics, like whatever real-time projects you have in your hand right now. So they have their own real-time databases. They have IoT streams or large-scale user interactions are there. Large amount of data we have to handle there. And there has been a huge increase in unstructured and semi-organized data as well. So whatever data is available there, it is already structured data, but sometimes it can be semi-organized also. So this data comes from diverse sources like social media, sensor reading, and large document data collection is there. So if I'm talking about, suppose data collection, so I'm doing the data collection from various different sources. Okay, so there can be a large number of sources of data as well as large document collection can be done there. Now handling this, it requires storage systems that delivers high throughput, scalability as well as flexibility. So whatever data models you are using, those models should be flexible, so that will also define again the working modularity of your project or domains, we can say. Now, the relational database system, which we are using from many years, they offer some strong consistency also, and there are strong properties of the database also, like ACID, that is atomicity, consistency, integrated, and durability also. So, all these are the properties which are given by traditional databases, traditional SQLs. However, they enforce strict rules for data structures also, requiring schemas to be set up in the advance. Modifying organized data structure requires significant downtime or financial expenses. Now, making the relational system times bigger, it requires buying more powerful, expensive computers like vertical scaling. Okay, so we are using the computers which are powerful, but again, if I'm talking about a server, then server it should be again more powerful. It can be an expensive computer also. SQL struggles with various nested data types, and they do not fit neatly into the tables. So we know whenever we are using the SQL system with the server sides, then there can be some of the differences in the pattern, or the patterns where we are using them for data storages, or making them workable or in operation. So those can be the issues in the traditional database. Now since it is the rise of NoSQL, it is available, we are using NoSQL. So NoSQL, that is not only SQL, we can say it is the short form. So NoSQL databases tackle SQL constraints by using schema-less and flexible designs. So we know that various schemas we use to design a database. It can be star schema, it can be snowflake, or fact constellation schema. Okay, so there are different types of schemas that we can create. But flexible designs are possible by using the NoSQL databases. They allow the users to add fields dynamically and support varied models like key value, document, column, and graph. So these are the types of the databases. Key value database is used many times. Like we know one of the NoSQL, it is the MongoDB, which is used nowadays. So MongoDB is also having these type of modules like key value database, document database, columnar or column family database, and graph database also. It is designed to scale horizontally, and they distribute data across clusters of regular servers. NoSQL, it is now go-to choice for IoT platforms also. So if we are using the database, or we have to create the database for IoT based projects, so we can use this NoSQL as a platform. Real-time analytics is also possible there, and social networking apps also you can use. Now, what are the objectives of my research here? So I have decided to examine the complementary strength and trade-offs of SQL and NoSQL systems for modern applications. Then to evaluate the performance of top NoSQL systems or databases under high volume workloads. Then to analyze how workload characteristics like consistency, query, complexity, scalability shape the database choices, and to suggest a decision-making framework to help professionals and educators to choose the right database technology. Now, about methodology. So first of all, we have decided to utilize a systematic literature review. So we have gone through some of the research papers, followed the guidelines by the scientist Kitchenham et al., supported by Parsifal SLR tool for rigorous reporting. So this is one of the tool given by the scientists. It combines the qualitative synthesis of pedagogical methods with a comparative analysis of database architectures also. We are comparing here the traditional databases with our database. It develops decision guidelines for academic curricula based on real world evidences. Then another, it is the research question. So for research, we should put some research questions in this format, like what NoSQL data models and database systems do teachers use most in college classes also. So like the traditional database RDBMS we are using, but new models if we are talking, so which SQL data models which we are using right now. So frankly speaking, I as a teacher, I'm using MongoDB. Then how do NoSQL systems outperform traditional RDBMS in speed and growth during real world tests? Then next question is, what teaching methods and tools do educators use to teach NoSQL, and what are the main problems and gaps that teachers face when teaching to NoSQL databases? So detailed research is required if we are talking about these questions. Then we have collected the data. So the sources are like major databases like IEEE Explore, ACM Digital Library, Scopus, Web of Science. Initially, records collected are 386, duplicated to 226 unique entries. Then full text assessment leads to the selection of 26 primary studies, and snowballing, like checking the reference list, we have added 6 more studies, bringing the total to 32 primary articles. About experimental overview, we have applied the things to Yahoo, then cloud serving benchmarks, workloads, then tested 3 top ranked NoSQL databases like Koch database, it is CoachDB also called as, and MongoDB. So these are the different types of NoSQL databases. Then record counts used like 100K, 1M, and 10M. and thread counts use 136 to measure horizontal scalability. So this is the framework of our methodology where we have used NoSQL. Sometimes we can use SQL also. So it is data. So we have to first of all check whether the data is semi-structured or unstructured, because we are collecting the data from various sources, different sources. So sometimes the data can be structured, sometimes it can be non-structured also. So if it is structured, then we can use NoSQL. Is a strict relational schema needed? So no. If we are not using any type of snowflake fact constellation schema, then we can use NoSQL. Does the application need horizontal scaling? If you want to use horizontal scaling, then yes, you can prefer to NoSQL like MongoDB Coach database. And is strong consistency required? So yes, you can use SQL as well as NoSQL. Then we have recording some of the results related to coach base or coach database. It shows moderate scaling and performs exceptionally well on crude operations. Then CoachDB, it exhibits linear scaling and it is highly efficient in scan heavy tasks like workload. Then MongoDB delivers strong performance and the lowest total runtime on mix or read or write workloads. Then 10M record scale, the workloads are like A to F, dominate Couchbase runtime. Then for horizontal scaling also we have checked like all three SQL databases scaled linearly when moving from 1 to 3 threads on regular hardware. MongoDB, it relies on in-memory indexing tricks in to boost mix overload or sorry workload speeds. Then so I'm concluding here. So the Couch database, it is best suited for apps requiring a lot of reading or mix, read or update at medium scale, because we know at server side there can be various updates happening. Couch database, it is the optimal choice for large scale operations that needs the heavy scanning. MongoDB excels at a wide variety of tasks on massive datasets, provided it is optimized with proper indexing and data splitting. And the optimal database strategy, it is not binary, but a workload aware balance of relational rigor and NoSQL flexibility can be done here. So these are some of the references. Thank you for this opportunity.
Thank you for your presentation, ma'am. Sir, if you have any questions for her.
Yeah, nice work done, Mrs. Narad. So I have one question that is for your data sets, what is the total size of the data set that you considered and to which region it got limited to?
Okay, so sir, up to 350 number of samples, first of all, we have collected, but that was not enough. So we have collected more and more samples from different databases. Up to 1000 of samples we have collected. But then we find out that if the samples are from one source, then it can give more accuracy or efficiency, we can say. So up to 1000 we limited, sir. But that can be the limitation of my work. We can have again another data set because there was much less time. So if we collect much more data, so that will be again increase the accuracy, we can say.
Okay, okay.
Yeah.
Thank you, thank you.
Yeah, thank you, sir, for the support.
Thank you so much for presenting, ma'am. And that concludes all of our presentations for this session. I sincerely thank all of our authors for their excellent presentations and contributions towards this session, and all of our participants for being a part of this international conference as well. I hope this session was informative enough for all of us. And on behalf of the entire team, thank you for the support that you have shown during this third version of this conference and all the previous two versions as well. We will be more than happy to have you for the fourth version in 2027. Just a small announcement, all the presenters would be getting their digital conference certificates through email within 2 working days, and the publications will be live after 7 to 8 months. So kindly cooperate with the team of BioCom 2026. I also thank our session chair, Shubhajit Roy Chaudhary, for chairing this session. This is just a small token of appreciation on behalf of Team BioCom 2026 and Global Knowledge Research Foundation. Thank you for your valuable presence. Sir, I now request you to give us your closing remarks.
Yeah, so overall it was a nice session, and we had presentations of varied nature, starting from database management to weather prediction pattern to biomedical um, related work. The sessions were of varied nature, although all of them were centered around AI and data science. Uh, while the presenters presented very nicely for each of those presentations, I found out that there were some shortcomings, which I thought that as I thought it's my responsibility to share my experience with you to point out those shortcomings so that you can work on that and considerably improve it down the line. And I wish you all the best for your future endeavors. Thank you.
Thank you very much, sir. I kindly request all the participants in this meeting to switch on their cameras for a quick snapshot. And we're done. So yeah, thank you so much, everyone. Have a great day ahead.
So I'm leaving